All right, folks, this is going to be the next video. In this video, we are going to be working with a drawing program, so to say. The program's intended function is to basically draw a face once we click a button. I'm going to provide a downloadable link for you, and with that link, you're going to be able to pull in all of this code that's already generated. So let me zoom way out. All right, you see we have all these blocks of code over here. I'm going to go through each individual block just to kind of point out, what function each block does. And then we're going to add to this to enhance it. Because ultimately what we're going to want to do is on the design side here, we have our canvas and then we have 6 buttons up top. And the buttons functionality is to forward, to move the Android guy here by a total of 10 pixels forward. And we also have the option to move the the Android guy to the right, meaning turn 90 degrees clockwise. We then have an up and a hide button here. So the up would basically be to pull, think of like a pencil or a pen. You pull up on the pencil, and therefore you can move the Android guy around, and no marks should be left on the screen, no drawing lines. And then when you put it down, it's basically like putting, pen to paper. And then when you move the Android guy around, lines will be drawn. So think of this as kind of like an Etch-a-Sketch kind of program. The hide button's function is to make the Android guy disappear. So when you draw a shape, obviously this could potentially overlay and block so that you don't get a clear look at the shape. So by hiding the Android guy, you get to see a clear look of the design that you just drew. The draw button, when I click that, what'll happen is rather than clicking this forward and right button and kind of manually, have the Android guy move, by clicking on the draw button at once, what you're doing is you're creating the face all in one shot. All right, so we're going to have to write some code for that. And then the reset button, what it should do, it should clear the screen, and it should, reset the Android guy back to the very middle of the screen. So when you download the template for this program, all of this is already going to be set up for you. So we don't have to worry about putting, the design side together because it's already put together for us. Everything is already named for us. All right, so everything is good to go. So what we can do is we can just jump right into the blocks, and we can kind of take a look at, what is what in here. So the first video that I'm going to create is just really going to talk about this code, go through the blocks, explain how they have things set up, and then I'm going to do a follow-up video, and the purpose of the follow-up video is to put the code together so we can get the Android guy here to draw a happy little face on our screen. All right, so with that being said, let's head over to the blocks area. All right, so I got this thing way zoomed out, so it's kind of hard to read. And as you can see, each block over here, it sort of looks a little jagged. And the reason being is because what I did, I right-clicked on the background and I did a collapse blocks. All right, because when you collapse a block, it allows you to create all that extra space in there. If you wanted to uncollapse them, we can go into expand blocks. All right, and when I expand the blocks over here, all right, this gives me all the code, as you can see, to make this program run. And there'll be actually more code that we'll need to write, and that'll be in the follow-up video. All right, so let me go back to collapsing the blocks. And also what I did, too, to get these all of these arranged, what I did was I right-clicked, and then I did a arrange blocks vertically. So put things nice and neat in vertical columns for me. As you saw, some of these blocks are actually very big, and they take up a lot of space. All right, so let's slide over here first. So we saw on the designer side here, we have a bunch of buttons up top here. And as I explained, what the purpose of each button, what it does. So let's take a look at the code to see if we can make more sense about each button. Now remember, all this code is already written for you, so you don't even have to worry about doing that. So we can just follow along and try to make sense of, what the buttons do. So let's start with the first button, which is the forward button. I just got to find it now because everything's shifted around now that I collapsed everything. It was over there on the left-hand side. Button hide, button draw, button up, button turn. There we go, button move. So this should be the forward button right here. All right. So button move is the forward button. All right, and as you can see, it's just the click event handler, and all we are calling is call forward and call display. So now we have to say, okay, well, what does this do? Because these are procedures that are written, that have already been written for us, and that we don't have to worry about writing. So if I needed to write these procedures, or if I went without doing a procedure, what would the code look like? Well, now what we have to do is I have to go into these purple blocks, and I need to find the call forward and the call display. All right, so we have our forward dot initialize, so that should be the procedure right there. We've got the reset call procedure. We have the turn procedure. We have the pen up, the pen down, and then that's the show and the hide procedure. That's a show procedure, the hide procedure, and then the display, and that's linking it to the canvas. So as you can see, we have the forward and we have the display procedure. So we're going to have to look at both of them, and let's see what we can make sense of this code here. So this is the big one out of all of them. And what we see over here, and the purpose of this code is to actually move the Android figure a total of 10 pixels in the forward direction. So depending on, where the Android guy is facing, all right, so forward in this is going to be basically on his right arm. So the forward should be in the upward direction. And then when we rotate, the Android guy forward will then obviously be in that direction. So when we rotate the Android, we're always rotating at a 90-degree angle. And so what the code in here, and we don't have to go into too much detail with this code, but what this code is showing us is we're creating local variables. And the purpose of the local variable is so we don't have to set a global variable. And again, remember when I talked about it earlier, a global variable is good to do, but it allocates more memory. And since we're finite in space, we want to make sure that we're only allocating memory, or the least amount of memory as possible. All right, and so that's why we're going to use the local variables. Plus, these variables being localized are only going to be used within this block and nowhere else. So there's no sense to allocate additional memory when we're not going to use it anywhere else. So when the forward is called, first thing we're doing is we're initializing a local variable theta. All right, and what the theta is we're grabbing the current heading of the Android. So being that we're working off of 90 degrees, it's quite safe to say that the angles that we're going to be dealing with are going to be 0 degrees, 90 degrees, 180, 270, and then 360, which obviously is 0 all over again. So the heading is the purpose of the heading is to grab that angle, and then we're initializing that variable theta to that angle that the current Android guy is going in. We're then now initializing local variables, delta x and delta y. All right, so now this is where we're grabbing the x and the y coordinates. Because if we look at the Android guy here, okay, we're going to be moving in the upward or in the right, upward, downward, or rightward, leftward direction. So at every single given point, we need to find, what is the x and the y coordinates. Every single time this Android guy moves a total of 10 pixels, what are the new x and the y coordinates? All right, and we're finding that by taking the cosine of the angle that we have over here, and then we're multiplying that by 10, and then they're having us round the value in the x direction because we don't want decimals. We want to deal with whole numbers because, what's 1.5 pixels? I mean, there really isn't. So we need to make sure that we have, whole numbers that we're dealing with. And then same thing for delta y as well. We're going to be using, because in the y component, you're always using your sine function. In the x component, we're always using the cosine function. Again, we go through the same process, this time multiplying by -1 to account for, moving upward versus going downward. Because again, remember, when we are working with the y component, when we go downward, we're going positive, so we're going to have to go more negative or less positive as we move in the upward direction. So what this block is now doing over here, it's doing a conditional check. If the pen is down, so if I go back onto my designer side, I have this up, and when I click on the up button, what'll happen, the words will replace and it should say down. All right, so it's sort of like a toggle switch. It's either up or it's down. And so what this function is going to do, it's going to check is the pen currently in the down position? Because if it is in the down position, what I want to do is I want to draw a line. And the line that I'm going to draw is going to be based off of our X and Y coordinates. Okay, we're going to get our global X's and global Y's. And the X1, Y1 is the current position where the Android guy is at. And then the X2 and the Y2 is where the Android guy is going to move to. And then it's sort of like connect the dots. I have a dot here and I have a dot here. I just now need to draw a line connecting those two dots together. All right, and it's all going to be based off of the position. We're using the get functions of the sprite. All right, and this is our Android.x, Android.y. Again, same thing, X and Y, where the positions were initially, where they end up going. And again, in order to get to where we're going, we're adding the values of delta X and delta Y together, plus the current position of where the Android guy is at. And then that would give us the ability to connect the dots from where we started to where we ended up. Now, if this condition fails, so if the pen is currently in the up position, we're just going to skip over this and we're just going to allow the Android guy to move into that direction, just like it would if the pen was down, but the only difference now is obviously we're not drawing a line in the process. All right, so that is what happens when we click on the move button and we call this forward procedure call. So now there's another procedure in here called display, so let's shift over. This one was all the way to the far right here. And let's see what this has for us. All right, so what we have here is we have a conditional check. If get global debug. So what they did here was they added in a variable global debug. All right, and currently right now it's set in the false state, meaning that there are no bugs present. But for whatever reason, if there is a situation where the program, the Android guy doesn't move in the fashion that it needs to, or if there's some other issues going on, the purpose of this is to actually sort of like, I don't want to use the word create a log, but it's sort of like that. It's creating, it's firing off a potential notifier. So that is setting the label debug. It's setting it's setting its visibility to true, which means the user should be able to see it. And then there's a label that is on the. I'll show you where it is. So let me click on the label. All right, so right here between the buttons and the canvas, there's a label up here. Obviously, there's nothing written there, so we don't see anything. But if there is an issue or an error, all right, it's going to then populate that field and let us know what the error is. And what it's going to tell us is it's going to tell us the heading of the Android person. We got then a space. That's what we're using this for, is to just create a space. It's going to give us the heading, the X coordinate, the Y coordinate, and then it's also going to provide us the canvas width and the canvas height. All right, so that is going to again show us. So whenever we call this function here, all right, we're basically we want to know exactly where the Android guy is heading. We want to know the X and Y coordinates and also the width and height of the canvas. All right, so we're going to set the visibility to true so we can kind of see that. And then what we want to do is we want to set the label debug also to true, so that it will switch from the original state, which was false. All right, so that being said, that will explain what's going on when we hit the forward button. So let's go back in here. Let me let me leave this expanded for now. So the next button that we have or that we dealt with after the forward button, all right, was the turn right button. So what I'm going to do is I'm going to go into, we got button turn right here. All right, so what do? Well, when we click on the button turn, we're calling the procedure turn, and then we're also calling the display procedure. So we already went through the display procedure, so I'm not going to worry about that, but let's go and check out what the button turn will do. All right, and I've got the procedure right here. And as you can see, we have a procedure set up, and what this is doing, by clicking on the turn button, it's altering the heading that the the Android guy is moving in. All right, and so we're using a modulus operator. And so for those of you that already taken all your math classes or are taking them, the modulus operator is just used when we want to factor in the remainder. So when we're doing usually divisions, there's usually remainders that are left over, and that's what we want. We use the modulo operator in order to focus on and factor in the remainders, because we can't just cut them off. Obviously, they're important. And so, again, all we're doing in here is our math. So we're taking the current heading, subtracting 90 degrees from it, and then adding 360 because, again, in App Inventor, we don't want to have negative numbers, being that the canvas is always, positive X, positive Y, and we're not going into a negative value. This is preventing that from happening. And then we divide it by 360 in order to get it to turn properly, and then taking a modulo of, because that will then align it to its proper orientation. All right, so that takes care of our turn button here. All right, so the next button that we have is our up. And we have button hide, button up right up here. All right, and so as you can see, we have our code. And so let's read this and see what this says. So it's asking us if we're going to compare some text. So if the button up.text, all right, so if we're going to get the value that's stored in that button, and if the value, which should be up, is equal to up, all right, then what we're going to do is we're going to change the value of the text that's in there to say down, and then we're going to call the pen up procedure. Otherwise, if we get the value, because we changed it to down here, so once this is changed to down, and we click the button again and we call this function here, well, down equals up, well, that's not true, all right, that's false. So we're going to skip over this, and then we're going to call the pen down procedure, and then we're going to change the value that's stored or set in that button up.text back to up again. So this creates this sort of toggle switch where every single time I click it, it's alternating between down, up, down, up. So let's take a look at the pen up and the pen down procedures and see if we can make sense of that as well. All right, so we got pen up and pen down right over here. So I click on the pen up procedure, and all we're doing is we're setting our variable global pen down to false. All right, and then same thing with the pen down. We're setting our global pen down to true. So we have our variable global pen down up here. All right, initially it's set to true. So all we're doing is we're switching the variable, the Boolean in here, from being true down to being false. And then this you're going to see is going to be called elsewhere, and it should make a little bit more sense as far as why we're only doing so little within these procedures over here. All right, so we'll come back to that in a second. So the next button we have is our hide button. All right, so we got it right up top here. All right, and as you can see, we have, so when I click on my hide button, again, we're doing the same thing. We're comparing our text. So we're going to call the button hide. If it's currently in its hide state, all right, if hide equals hide, then what we want to do is we want to hide the turtle. Otherwise, if it does not equal hide, well, then it's going to equal show. And then therefore show does not equal hide. So we're going to skip over that, and then we're going to call the show turtle procedure. All right, and so again, we go down here, click on the show turtle. It's going to be very similar. And let me actually click and drag this one over here so we can see them side by side. And as you can see over here, we have the show and the hide turtle. The show turtle, again, what we're doing is we're setting the visibility of the Android guy, all right, to true, meaning the little Android guy that we have in the center over here, all right, by setting the value of visibility to true means we should be able to see the Android guy. Over here, when we hide the turtle, when we set the Android visibility to false, what that means is by setting the visibility to false, it shouldn't be visible anymore, and that's why this thing will disappear. So we can toggle it basically being present or being hidden, when we hit that button. And again, as we see over here, when I click on the show, what I'm doing is I want to change the value of the text that's being stored in the button hide to hide, so that when I click it again, as I said earlier, hide doesn't equal show, so therefore we're then going to execute the hide turtle, and then I want to hit and set the value of button hide back to show again, so that when I click it again, show will equal show, and therefore we can show the turtle and then reset this to hide, so on the next click it should disappear again. Right, so again, acting kind of like a toggle switch in between. All right, so the next we have is our draw and our reset button. So let's actually just do the reset button because that's, well, actually, I don't want to say fairly simple. There's a lot of stuff going on with each. So we have the reset button down here. So again, what we're doing is we're calling reset and we're calling display. So again, we already went through display, so we're not going to go through that again. But now what we have is the reset function over here. All right, and as you can see, this is what we're calling when I click on reset. So I'm calling canvas1.clear, okay, and we already used that function. That's the built-in procedure that we used back in the Paint app. When I call the canvas1.clear, it wipes the canvas clean. So the purpose of this program, again, is to, like an Etch-a-Sketch, is to draw shapes on my canvas here. So by calling the canvas clear function, it's going to wipe away all those shapes, so you don't have to see all the scribbles on the background anymore. We're setting the visibility of the Android to true, so we can see the Android. We're setting the heading back to 90 degrees. So as you can see, initially it is rotated clockwise 90 degrees. We're going to set the canvas paint color to the global pen color. So the global pen color is set to black. So we're always going to be using black ink when we're drawing, though that can be changed even on the designer side as well if you want. And we want to move the Android guy. Basically, as you can see now, when we start the Android, before it moves, it's directly in the center of our screen. So what we're going to do is we did this in the Pong game. All right, we're going to use the move to procedure that is found within, that's your image sprite here. I'm sorry, that's your, it should be found in your canvas. So let me just double check that really quick. And draw line. Oh no, I'm sorry. It's in your it should be your image sprite. There we go. So it's in your image sprite called move to. So again, where are we going to move the Android guy? Well, we want to make it right in the center of the screen. So we're going to grab the dynamic value, that's the canvas width and canvas height, that you can find in your canvas function over here, all the way at the bottom, or I should say close to the bottom. All right, so you got your canvas width down here and your canvas height over here. And then we're going to divide those values by 2. So if you're dealing with a 400 by 400 screen, well, we want to get the midway point, so 200 by 200. All right. And then we're factoring in the global X and the global Y values to make the fine-tuning adjustments that we need to position the Android guy where he needs to be. All right, so when I click the reset button, that's what happens with that. And then lastly, when I click the draw button, all right, I'm calling the procedure draw. So, and that's right over here. So when I click on that, all right, showing my alert notice. So to get me to draw, you have to define the draw procedure. All right, and so therefore, if it's not going to work yet, and the reason being is because in the second video, this is what we're going to need to do, and we're going to have to add all the code in here. So when we click draw, all right, we're going to have a face drawn on the screen. All right, and then lastly, screen 1 initialize. So remember, whenever we click on the screen 1 up here, which is the parent function, and we go to the event handlers and we grab the initialize event handler, that means the moment the program loads, we need to execute this code right away. So what we're doing is we're changing the screen orientation so that it's in portrait mode. So if somebody has it turned sideways and is in landscape mode, we're going to orientate it into portrait mode only. We're going to call the reset procedure, which again wipes the screen clear of everything and makes sure that the Android is moved to the middle of the screen. And again, we're calling display. right over here. So again, we are basically grabbing the heading information, the X and Y coordinates, and then the width and the height of the screen. Right, and then the rest over here are just our global variables that are being set to a specific value. As you can see, pen color being black, debug color being false, and the X and Y coordinates being 20 and 15. All right, so that is all the code. And like I said, if you wanted to build this program, you'd have to build this in its totality by yourself. But the link that I am going to post for you is going to allow you to have all of this code put into your App Inventor as it is already. So now what we're going to want to do, as I said, is we want to have this Android guy, once we click the draw button, we want him to automatically draw a square-shaped face with 2 eyes and a mouth. All right, because right now it'll work, but you'd have to, like an Etch-a-Sketch, you'd have to hit forward every time in order to move the Android guy by himself. We want to autonomously have him do everything on our own by the code that we write. All right, so I'm going to cap video 1 for there. That's basically all the components that we're dealing with today. So let me zoom out a little bit so you can kind of see. And like I said, what we are going to do, gosh, I got to zoom out even more. What we are going to do is we're going to now, I'm going to cut this short. I'm going to go into another video. And the purpose of the next video is to go through and make sure that we are putting in that additional code so we can see how the face will be drawn. All right, so I'm going to stop it from there. We'll see you in a few minutes.